Hi everyone. Let us discuss this example. See, in this example, we have to verify Green's theorem for a given function. Verifying Green's theorem, that means we are familiar with the statement of Green's theorem. We find the value of left hand side, we find the value of right hand side, and we prove that both of them are equal, and we declare yes, Green's theorem will be, it is verified. Getting? So the same procedure we are going to follow. So let us write the statement of Green's theorem first. So let me write here by Green's theorem. Okay, so Green's theorem. What is the statement of Green's theorem? Integration over C P dx plus Q dy is equal to double integration over R delta Q by delta x minus delta P by delta y dx dy. So this is a statement of Green's theorem. Okay, so we are going to find the values of both sides, left hand side and right hand side. First of all, we will start to work on right hand side. Okay, so let us start to find its value. But for that we need to have P and Q. Have they given P and Q? So instead of P and Q, they have given a vector valued function f of xy. It has two components. You can easily see here. The first component is nothing but our P and the second component is nothing but our Q. So let me write it here. So here, what is our P? Let me write P is equal to the first component 2xy minus x square, and the Q is x plus y square. Okay, so let us find partial derivatives. We have to find derivative of P with respect to y. So you know that when we take partial derivative with respect to y, we consider x is a constant. So 2xy, we have 2x is a constant, derivative of y is 1. So let me write 2x only, minus x square, but x square is a constant since we are finding derivative with respect to y, so its derivative will be 0. I will not write that thing. 2x minus 0, you will have 2x. Let us find delta q by delta x. Derivative of q with respect to x. Addition is there, we can take separate derivative. Derivative of x is 1 plus y square. Y is a constant. Since we are finding derivative with respect to x, its derivative will be 0. So this thing we have got. Okay, so let us write right hand side. Right hand side is equal to double integration over r delta q by delta x, which is 1, minus delta p by delta y, which is 2x, and dx dy or dy dx you can write. See, to find the value of this double integration, we need to have limits. Okay, so we have to find the limits of this double integration. Let me tell you one thing, what is C and what is R. So here always we have a curve, closed curve, getting? So that is nothing but C. And region bounded by C, that is nothing but R. Okay, so this type of C and R we have. So let us find the given region here. Okay, so let me write what we have. R is a bounded by closed curve C formed by, okay, so let me write R is bounded by what we have, y is equal to x square. See, power of x is 2, power of y is 1, so it represents a parabola. So simple funda we have, if power of one variable is 2 and the power of second variable is 1, it represents a parabola. So this is also a parabola. Power of y is 1. That means this parabola is symmetric about y-axis. So let me write a parabola symmetric about y-axis. About y-axis. Okay, in short I have written. And second equation is x is equal to y square. So this is also a parabola. But this time the power of x is 1. So this parabola is symmetric about x-axis. A parabola symmetric about x-axis. Okay, so let me draw a diagram here so we can easily understand. This is y-axis, x-axis. Okay, this is y-axis and this one is x-axis. Y is equal to x square, parabola symmetric about y-axis, and y has positive sign. That means that parabola opens in the direction of positive y-axis, right? So that parabola will be like this. See, x is equal to y square, right? Parabola is symmetric about x-axis, but x has positive sign. That means parabola opens in the direction of positive x-axis. If I write minus sign here, that parabola will be like this, but x has a plus sign, so the parabola will be like this. Okay, so let me write this is x is equal to y square and this one is y is equal to x square. Okay, so region bounded by these two parabolas, that means you can easily understand this is the given region of integration. Okay, so it is important to find the point of intersection. So there is a very simple technique to find point of intersection. We put one equation in second equation, we get a point of intersection. I will do the same. To find point of intersection, points of intersection, we will put one equation in other. We put y is equal to x square into x is equal to y square. Let us do that. So x is equal to, I am putting y is equal to x square. So x square square, that means you will have x raised to 4. Let us take all equations on one side. So therefore 0 is equal to x raised to 4 minus x. We can easily take x common. So x cube minus 1 is equal to 0. It means either first term is 0 or the bracket is 0, since the product is 0. So you can easily see x is equal to 0 or x cube is equal to 1, or simply you can say x is equal to 1. X cube is equal to 1 means x is equal to 1. So yes, let us find the points now for x is equal to 0. We got the values of x, but we are interested to find points of intersection. We want points. X is equal to 0. You can put that value in any one of these two equations. I will put it here. So you will have y is equal to 0, y is equal to 0. So the point is 0, 0. Both of them are 0. And for x is equal to 1, let us see what we will get. X is equal to 1. You can put value of x is in any one of these two equations. I am putting here 1 square is 1. So the point is 1, 1. So the first point of intersection is 0, 0 and the second point of intersection is 1, 1. Okay. So this is the region of integration we have got. Okay. Yes. So there is no more space to write. Make a screenshot of it first, then I will go further. Okay. So now to find the limits, we should consider a strip here either parallel to x-axis or y-axis. I will consider a strip parallel to y-axis. So let me mention here, consider a strip parallel to y-axis. Okay. So let me show it here. We have a strip now parallel to y-axis. See, we have a very simple funda. When we have a strip parallel to y-axis, we consider bounded below, bounded above, left to right. Okay, in first unit double integration, okay, that we have already seen that thing. So let me mention here, our strip is parallel to y-axis, so I should write y varies from y is equal to y is equal to, and then I should write x varies from x is equal to x is equal to. I will follow our funda bounded below. The strip is bounded below by some part of this parabola whose equation is y is equal to x square, and strip is bounded above by the second parabola whose equation is x is equal to y square. But see, I have already written y is equal to, that means we should express this equation in terms of y is equal to. For that, I will take square root of both sides, positive square root, so y is equal to root x. Okay. So bounded below, bounded above, that task is finished. Now left to right, we have to move strip from left to right. See, at left, the strip will go up to this point. Getting the strip is moving like this. As you can see here, this pen is moving like this. So strip is also moving from left to right. So strip will start at this point where the value of x is 0. And strip will move like this slowly, and it will go up to this point, okay, to cover the complete region. And here the value of x is 1. So x varies from 0 to 1, right? So in this way we got the limits. So therefore we were solving right hand side integration. See, double integration. The function, let me check here. The function is 1 minus 2x. Our strip is parallel to y-axis, so I should write dy first, and after that I should write dx. As well as inner integration with respect to y, so its limits are x square to root x, and limits of x, outer integration with respect to x, so 0 to 1. So let us solve it, integration 0 to 1. First of all, we are solving the inner integration which is with respect to y. So this bracket does not contain any y. So it's constant. It will come outside the inner integration. So 1 minus 2x will come outside. Integration x square to root x dy and dx. So this is equal to integration 0 to 1, 1 minus 2x. Integration of dy is y, okay? Y x square to root x dx. Let us put upper limit, lower limit. Integration 0 to 1, 1 minus 2x. Putting upper limit, root x minus x square dx. See, now we have got a product of two brackets, right? So we should multiply. So let us multiply one by one. So integration 0 to 1, right? So 1 into root x, you will have root x. Root x means x raised to 1 by 2. Let me write in this way. 1 into x square, so minus sign it has, so minus x square, minus 2x root x, minus 2x root x means x raised to 3 by 2, right? And minus minus plus 2x cube, right? 2x cube. Let us check again, huh? So yes, 2x into x square, x cube. So addition subtraction is there. It's very simple. You can take separate integration. So integration of x raised to 1 by 2 is x raised to 3 by 2 by 3 by 2 minus integration of x square is x cube by 3 minus 2 is constant. Integration of x raised to 3 by 2 is x raised to 5 by 2 by 5 by 2 plus 2 constant. Integration of x cube is x raised to 4 by 4, 0 to 1. So first of all, I will put upper limit 1. Let us put 1. So 1 raised to anything 1, I can directly write 1 upon 3 by 2 minus 1 by 3 minus 2 upon 5 by 2 plus 2 by 4. Since if you put 1 raised to anything, you will always have 1. 0, if I put 0, all terms will give 0, so no need to write anything. Let us simplify this one only. So 2 is in denominator of denominator will go to numerator, minus 1 by 3. That 2 is also in denominator of denominator will go to numerator. So 2 into 2, 4 minus 4 by 5 plus 2 to cancel. So it's 1 by 2. See, both of them have same denominator. So you can simply subtract numerator. 2 minus 1, 1 by 3 minus 4 by 5 plus 1 by 2. We need to cross multiply, getting? So 5 minus 12 by 15 plus 1 by 2. So it is minus 7 by 15 plus 1 by 2. Again we need to cross multiply. So it is minus 14 plus 15 by product of these two, which is 30. So it is 1 by 30. Okay, so please keep in your mind the value of right hand side just now we have got, which is 1 by 30. Now we have to work on left hand side and we will find its value, and finally we will prove that both of them are equal. There is no more space to write. Make a screenshot of it, then I will go further. So now let us work on left hand side. Okay, so let me write left hand side, which is equal to integration over c p dx plus q dy. Okay, so same thing we can write in this way also, integration over c pi plus qj into dot product is there dxi plus dyj. Okay, same thing we can write in this way also. So this is equal to integration over c. This is nothing but f bar and we call it as dr bar. So this is the line integration over c, f bar dot dr bar. But as you can see here, c means what? Boundary. Okay, so this boundary is formed by two parabolas. That means this has two parts, this one and this one. So let me call it as c1 and this is our c2. So therefore here we can write integration over c1 plus integration over c2. I hope you have understood. So here we have a two curves, so that's why we should solve line integrals for c1 and c2 separately, and at the end we have to add them to get the value of this line integration over c. So let us start to work on c1. Okay, so for c1, so what is equation of c1? So equation of c1 is y is equal to x square. As you can see here, y is equal to x square, right? So here I am putting x is equal to t. X is equal to t. But see, if you put x is equal to t here, y is equal to what? T square. X is equal to t, then y is equal to t square. You can see here x varies from where to where? 0 to 1. X component, you can easily see x varies from 0 to 1 and x is equal to t. So therefore here t varies from 0 to 1. You are getting? I am converting the entire problem in terms of t. So that's why I should have the limits of t. X is equal to t, so therefore limits of x will be limits of t. So x varies from 0 to 1, so t will also vary from 0 to 1. So therefore parameterization is, so parameterization of that course C1 is alpha defined on closed interval 0, 1 to 0, 1 to R2 as alpha of t is equal to x. X means the first component, which is t, and y is t square. So this is the required parameterization. Okay. So after having parameterization, what we do? We find alpha dash of t and we calculate f of alpha of t. Let us do that. Okay. So yes, just a minute. I'm going to write here. So alpha dash of t. So that means derivative. It has two components. We will take derivative separately. Derivative of first component, derivative of t is 1, derivative of t square is 2t. We got it. So now f of alpha of t. Okay, f of alpha of t. F of alpha of t. Let me put this alpha of t there. So it is t comma t square. So this is a given definition of f. I am going to use this definition to find its value. If you compare, you can easily see x is equal to t and y is equal to t square. So in the definition also, I will put x is equal to t and y is equal to t square. Let us see what will happen. So this is equal to, I am putting x is equal to t, 2, and y is equal to t square. T into t square, t cube minus x is t. So this is t square, x is t plus y square. That means t square square t raised to 4. So this is f of alpha of t. So let us follow the definition now. Therefore, integration over C1 is equal to, it has parameterization alpha having limits 0 to 1. Let me write. So definition of line integral says here we have to take a inner product of f of alpha of t comma alpha dash of t dt. So this is equal to integration 0 to 1 inner product f of alpha of t. Just now we have calculated 2t cube minus t square comma t plus t raised to 4 comma alpha dash of t, it is 1 comma 2t, right, dt. So you know well how to find the value of inner product. Okay, component wise multiplication, 1 into this one you will have 2t cube minus t square as it is, plus 2t into this one, that means 2t into t, 2t square, plus 2t into t raised to 4, 2t raised to 5 dt. Now we have to find the value of this integration, but there is no more space to write. Make a screenshot of it, then I will go further. So let us continue it here. So this is equal to, addition subtraction is there, we can take separate integration, 2 as it is. Integration of t cube is t raised to 4 by 4 minus integration of t square is t cube by 3. Here 2 as it is. T square is t cube by 3. Actually it was better if you add it. Okay, we can directly, we have the answer. Plus 2 integration of t raised to 5 is t raised to 6 by 6, 0 to 1. So let us put 1, so 2 by 4 minus 1 by 3 plus 2 by 3 plus 2 by 6. It's very easy, since if you put 1 raised to anything 1. If you put 0, all terms will be 0. 2 by 4 means 1 by 2. This 2 by 3 minus 1 by 3, that means we'll have 1 by 3. And this is 1 by 3 again by cancelling 2. So 1 by 2 plus 2 by 3. If you cross multiply, 3 plus 4 by 6. So it is 7 by 6. So value of line integral along C1 is 7 by 6. Now we have to find the value of line integral over C2. Okay, make a screenshot of it, then I will go further. So now we are going to find the value of line integral along C2. As you can see here, the equation of C2 is y is equal to x square, right? This time I will put y is equal to t. So easily we'll have the value of x. See, in case of parameterization, what we do, we have a 2 variables, right? Sometimes we will have 3 variables also. So we convert the entire equation in terms of single variable. Okay, so here I'm trying to express it in terms of t. So what will I do? I am putting y is equal to t. Y is equal to t. So if you put y is equal to t, obviously x is equal to t square. As you can see here, y varies from 1 to 0. Okay, since you need to see the direction of C2, we have to cover a complete circle. Okay, not the circles, curve C. So C1 having a direction from this 0 0 to 1 1 and C2 having a direction from 1 1 to 0 0. See, so for that what will I do here? Parameterization of minus C2 is minus C2, that means opposite direction I am taking, getting? So minus C2 I am calling it as beta. Now it is from 0 1 to R2, getting? If you consider a C2, it will be from 1 to 0. But see, if you consider minus C2, it will be from here to there. No, so it will be from 0 to 1. So that's why we can consider this interval defined as beta of t is equal to x. What is our x? X is t square, and y. What is our y? T. Okay. So we need to have beta dash of t. After that, f of beta of t also required. So let us find beta dash of t. It is quite easy. Derivative of t square is 2t. Derivative of t is 1. That's it. We want f of beta of t also. F of beta of t. Let us find f of beta of t. This thing we have to put here. So t square comma t. So we have to follow the definition of f which is given in problem. If you compare x is equal to t square, y is equal to t. So at a place of x we have to put t square, at a place of y we have to put t. Let us do that. Let us see what we'll get. 2 t square into t cube, okay, minus x square t square square, it will be t raised to 4 comma x which is t square, y square t square, that means t square. Okay, so let me write here 2t cube minus t raised to 4, and this is 2t square. So yes, finally we got f of beta of t. So let us find the value of line integral now. Okay, see, actually we want the value of line integral over C2. But see, here we have found out the parameterization of minus C2. So integration over C2 is nothing but minus integration over minus C2. Okay, so this is equal to minus integration C2 having a parameterization beta which is defined on closed interval 0 to 1. Simply I will follow the definition f of beta of t comma beta dash of t dt. So this is equal to minus 0 to 1. Let me put f of beta of t, which is this one. So let me write here, it is 2t cube minus t raised to 4 comma 2t square. Okay, beta dash of t, what is it? 2t comma 1, 2t comma 1. So you know well how to find the value of inner product. Component wise multiplication, first component into first component plus second component into second component. So minus integration 0 to 1, 2t cube into 2t, that means 4t raised to 4 minus 2t raised to 5. Getting? I am simply multiplying. Okay, and 2t square plus 1, that means 2t square dt. So addition subtraction is there, we can take separate integration. Minus 4 as it is, integration of t raised to 4 is t raised to 5 by 5, minus 2 integration of t raised to 5 is t raised to 6 by 6, plus 2t cube by 3 with limits 0 to 1. I am putting 1 first and then I will put 0. If you put 1, if you take any power of 1, you will have 1. So let me write directly minus, this is 4 by 5, minus 2 by 6, that means 1 by 3, and plus 2 by 3. If you put 0, you will have 0 obviously. So minus, this is 4 by 5, 3 having a same denominator. So this is 2 minus 1, 1 by 3. If you cross multiply, this will be 12 plus 5, that means minus 17 by 15. This is value of line integration over C2. Value of line integral over C1 we have got, over C2 also we have calculated. So let us add them. So we'll have the value of line integral over C. Make a screenshot of it, then I will go further. So then value of left hand side which is nothing but integration over c f bar dot dr bar is equal to line integration over c1 plus line integration over c2. Both values we have already calculated, so I have, let me put here, so it is 7 by 6 and value of second is minus 17 by 15. Okay, so actually plus sign is there, but this number already has a minus sign, so it will be minus. So yeah, to make the denominator same, I should multiply it by 5, so it is 35. I should multiply it by 2, so 34 by 30. So having a same denominator, you can easily subtract 1 by 30. Equation number 2. Do you remember that value of right hand side already we have calculated and it is 1 by 30. Here also we have got 1 by 30. So from 1 and 2, from 1 and 2 we can declare left hand side is equal to right hand side. Therefore Green's theorem is verified. Okay, so in this way we have verified the Green's theorem. Make a screenshot of it, then we will stop. Thank you. Bye bye.